In this video, we'll be seeing about the current sources. So here the current sources are classified as ideal current source and the practical current source. First, we'll see what is the ideal current source. These are the current sources which will be maintaining a steady state current flow at all times, okay, across its terminals, which are unaffected by the voltage fluctuations across its terminals. That is, it will give you a constant current at its terminals irrespective of the voltage appearing across its terminals. Fine. So these are called as ideal current source. And this is the symbol for ideal current source. And here a load is connected across the current source. Okay. So you will get such type of characteristics for this circuit, where you will be having the load current that is equal to the source current. Okay. And here, irrespective of the voltage, the current remains same throughout. Even you decrease the voltage, you increase the voltage, the current which is drawn here across this current source, it will be same, it will be constant. Okay. So practically it doesn't happen. So you must have a resistance here. So for this you will be seeing the practical current source. So practical current source, here you will be having a high internal resistance which will be in parallel to the current source. In the previous video, we have seen the practical voltage source, where you are having a small internal resistance in series with the voltage source. But in current sources, you will be having a high internal resistance in parallel with the current source, which is represented by RSH. Okay. Now, because this RSH is high, okay, and also because of this internal resistance, the current through the terminals, it will decrease. Okay, it will decrease with increase in what? With increase in voltage. Actually, this should be VL. Okay, this should be VL. It is not IL. It is VI characteristics. So the current will decrease across the load. Now, here you can write it as load current plus the current through the resistance. Okay, it is equal to the source current. So the source current is divided into two branches here. So the source current is equal to load current plus the current across the resistance. And always the load current will be smaller than that of the source current. So for ideal current source, RSH will be infinity. That is, for ideal current source, you don't have any resistance here. Okay, actually in practical you have a resistance in parallel with this current source, but in that is a ideal current source, you don't have any internal resistance which is in parallel to it. So here RSH will be 0. So here RSH will be infinity. Sorry, it will be infinity, not 0. It will be infinity because it is a high internal resistance. And again, this can be classified as time invariant current source and time variant current source. So this is a symbol for time invariant current source. And here the current is not varying with time. These are also called as DC sources, and these are usually represented by capital letters. This is the time variant current source. Okay. Here the current is varying with time, and these are also called as AC sources. And here these are usually represented by small letters. Here you can see it is represented by capital letter, and here it is represented by small letter. So we'll brush up once again here. So what it is, this is the symbol for ideal current source. Here we are connecting a load, okay, across the ideal current source, and this is the VI characteristics for this, where you will increase or decrease the voltage, the current remains same. Okay, that is the load current will be equal to the source current. In practical current sources, there will be a high internal resistance which will be connected in parallel to the current source. Okay, and here the source current, it is the sum of the load current and the current across the resistance, and always the load current, it is smaller than that of the source current. And this is the VI characteristics of the practical current source, This is VL, it is not IL, this is VL. Okay, so here this is for ideal current source and this is for practical current source. As you increase voltage or decrease voltage, there will be a variation in the source current. As you increase the voltage, the source current gets decreased. Fine. Not source current, sorry, the load current gets decreased. So this is for practical and this is for ideal. So for ideal, this is the source current, this is the source current will be equal to the load current, whereas for practical current source, the load current decreases as you increase the voltage. And for ideal current source, the internal resistance will be infinite. Okay, so here this was about the current sources. Thank you.